Hello engineers, welcome to the new video of the course, and in this particular video we are going to continue the further discussion, which we left in the previous session. So if you could remember, in the previous session I asked you this particular question, that how exactly a conductor is able to transfer heat and electricity and why insulator fails to do so. So I believe that you all guys have tried your best to think upon this particular question. Now it's my turn to explain you the entire logic and the scenario that is present behind this particular question. Okay, so for that what we'll do, we'll just take one example. Let's suppose this is me. Okay, this is me. I'm staying at, let's say, point A. Okay, and at point B this is my girlfriend. So my girlfriend stays at point B. Okay, my girlfriend stays at point B. So obviously this is a hypothetical girlfriend. Okay, so my girlfriend stays at point B. Okay, and you are my student and you are her neighbor, so you are staying somewhere close to her. Okay, so what I want to do is that I wrote certain letter to her and I want to give that particular letter to her, but I'm unable to go at point B due to some reasons. Okay, and since you are my obedient student, so what I'm expecting is that you will transfer that particular letter from point A to point B. So basically you will take the letter from me and you will give that letter to her. Okay, so this is just a random example, but what outcome can we take from this particular example? So you, since you are my obedient student, what you did, you just transferred the letter. Okay, or you just give that particular letter from me to her. Okay, I hope you are able to understand this. You took that particular letter from point A to point B. Let's suppose if you are not present in this entire scenario, I won't be able to pass that particular letter to her, or I won't be able to give that particular letter to her. Okay, I hope you are able to understand this. So what does that mean? You are acting as a medium in between both of us. Okay, you are acting as a medium in between both of us. I hope you are able to understand this. In this similar term, there is certain medium in the conductor. So let's suppose if this is my conductor, and let's suppose if this is my insulator. Okay, so in case of conductor, there is some medium which is present inside the conductor. Okay, whereas in case of insulator, this particular medium, it is absent. Okay, so due to this particular medium, what is happening? The energy which are supplied at point A or which are provided at point B, this energy can be heat or it can be electricity. Okay, it was able to transfer from point A to point B. So I will be able to sense heat or electricity exactly at point B. Okay, so this is the scenario in case of conductor. So basically you can relate this particular entire example with the help of with the conductor. Okay, again I'll quickly revise what I explained. So I'm staying at point A, my girlfriend, hypothetical girlfriend, okay, she is staying at point B. Due to some reason I was unable to give that particular letter to her. Okay, so what I did, I asked you, since you are staying very close to her, you are her neighbor, right? So I asked you to give that particular letter. So what you did, you just pick up that letter from me and you just gave it to her, and I expect you that you didn't read that particular letter in between, right? Of course you won't, since you are my obedient student. So what exactly you did over here? You just pick that letter, you gave it to her. So basically you are like a medium in between both of us. Similarly, in case of conductor, whenever a heat or electricity is supplied at point A, it is quickly sensed at point B. Why? Because in case of conductor there is some medium. Okay, whereas in case of insulator, if I supply certain heat or energy, okay, from point A, let's suppose if I supply certain energy, it can be heat or electricity, I won't be able to sense this particular energy at point B. Why? Because this particular medium is absent in case of insulator. Okay, so basically insulator acts as the resistor. Okay, it won't allow the energy to flow from point A to point B. I hope you are able to understand this particular concept. Okay, now let's proceed further and let's try to understand that what exactly this medium is. Okay, so we all know atom has nucleus at the center which has protons, that is positive charge, and electron revolves around this. Okay, so this is my nucleus, this portion, this is my nucleus. Okay, and this is the electron. As of now, you don't focus upon which atom it is. Okay, just assume that this is a random atom. We are not focusing upon what exactly this atom is. Okay, but what we know, I hope you all guys know this particular concept, right? Concept of atom. You have a nucleus at the center and electrons revolve around that. So this is what we can assume as of now. Okay, great. In case of conductors, the attraction between nucleus and the outermost or the valence electron of that atom is very, very less. What does that mean? That means, you see this particular attraction. Let me take this one. So the attraction between the electrons and the nucleus. So this attraction between electrons and nucleus is very less. But mark my words, as I clearly mentioned, in case of conductor, the attraction between nucleus and the outermost or the valence electrons. Okay, so it might happen that there might be some other electrons revolving around this particular nucleus, but we are talking about the outermost electron. That means the electron which is present in the last shell. Okay, so that is the outermost electron or the valence electron of that atom. So the attraction between the valence electron, okay, or the electron which is present at the last shell, in the last shell. Okay, so the attraction between that electron and the nucleus of the atom, it is very, very less. Okay, now since this attraction is very, very less, so what we can do, by supplying certain energy, or as I clearly mentioned, thus by applying very less energy, we can remove that electron very, very easily. So that means what? Now you can relate this particular entire thing. So if I supply certain energy, this energy can be heat or electricity. As of now, that is not the great concern for us. We are supplying certain energy. So what we saw is this electron which was present over here, okay, which was revolving around this particular nucleus of the atom. It came out of this particular shell and now it became free electron. Okay, again I'll just repeat. See, in case of conductors, this is very, very important. In case of conductors, the attraction between the nucleus and the outermost or the valence electron of that atom is very, very less, as I clearly mentioned, due to which, thus by supplying very less energy, we can remove that electron very easily. Okay, so you see this particular electron, now it is a free electron, and this electron only, it is responsible to conduct or to pass the energy, responsible to pass or to conduct or to transfer, whatever you want to write, the heat or electricity. We'll see that, don't worry about that. Okay, I hope you are able to understand this entire scenario. So basically in our example, you are like that particular electron. Okay, I hope you are able to understand this particular entire scenario. Okay, so does that means in case of insulator these electrons are absent? Well, yes, this is what it means. Okay, so I'll just write this particular point over here so that you should not get confused whenever you will refer my PDF. Just move it over here. So this is my conductor, this is that particular free electron. Okay, this is my point A and this is my point B. Okay, so I'll just write over here, because of free electron energy, that is heat or electricity, whatever it can be, is transferred. Okay, from point A to point B. So electrons will move in this particular direction, right? Or basically the energy which we provided, it is supposed to move from point A to point B. We are able to sense at point B. This is what we can see as of now. We don't know how exactly things work internally. We are just guessing. Okay, we are just guessing, because what we are doing, we are just going step by step. Okay, we had not decoded everything as of now. We are just going step by step. Okay, so I'll just write this particular point. So by supplying by supplying very less energy, very less energy, comma, electrons are set free. Electrons are set free in case of conductors. In case of conductors, okay. So these electrons are responsible these electrons are responsible to transfer energy, that is heat or electricity, from point A to point B. I hope you are able to understand this particular concept. Okay, by supplying very less energy, as you can see, electrons are set free, okay, in case of conductors. Okay, so this is all true in case of conductors only. So these electrons are responsible to transfer energy from point A to point B. So does that means these electrons are absent in case of insulator? Yes, that is true. Okay, and why the electrons are absent in case of insulator? Well, the reason is quite simple. First of all, you'll see that in an insulator, the attraction between the outermost electron and the nucleus is very high. So this is my outermost electron and nucleus. So you see over here, this is my outermost electron and the nucleus. So the attraction between outermost electron and nucleus is very high. Okay, and since it is very high, so I clearly mention, one second, let me just draw this electron. Yeah, therefore even by applying sufficient amount of energy, we cannot remove that electron. Okay, so even though if I apply a high amount of energy, okay, energy, that means whatever that is, electricity or heat, when by applying a lot of heat, these electrons are not set free. Why? Because the attraction between the nucleus and this particular electron, it is quite high, so these electrons won't be free. Okay, and as I clearly mentioned, since electrons are not free, so there isn't any a medium, right, that is present in between point A and point B, so that it can conduct the energy from point A to point B. So this is what I clearly mentioned. Since there is no medium which can transfer the heat and electricity from one point to another, therefore insulators cannot pass heat and electricity through them. Bad conductors of heat and electricity, which we had already discussed. Sorry. So I hope you are able to understand this, that why exactly the conductors is able to transfer heat and electricity through them, while why insulator fails to do so. Okay, so yeah, this is, let's assume, I'll just change the color to blue. Yeah, let's suppose this is my insulator. Okay, and this is my point A and this is my point B, and there are no free electrons. Okay, in between point A and point B. So let me just write a few points which we discussed. I know I'm taking a lot of time, but believe me, once if you understand this particular concept in detail way, okay, so you will be able to understand the further thing, that is what exactly is a current, how a current is generated, what is the voltage, how electrons flow from point A to point B, and so on. So all of these particular concepts will be very, very easy to understand. Okay, so let me just write this particular point, as there isn't any free electron in case of insulator, as there isn't any free electron in case of insulators, therefore the transfer of energy transfer of energy does not takes place in case of insulator. Does not takes place in case of insulators. That is the basic idea. Okay, I hope you understood each and everything that we discussed till now, and let me check if there is, yeah, this is the point that we need to discuss, that how exactly things work. Let's say if this is my conductor. Okay, let's assume that this is my conductor. Let me change the color. Let's assume that this is my conductor. So how exactly things work? So let's suppose this is my point A, and let's assume that this is my point B. If I apply, let's suppose, heat over here. Okay, I provided certain heat, due to which what is going to happen? As I provided certain heat, what we learned is that the electrons which were present over here, okay, so these electrons which were present over here, what is going to happen with them? The moment they get certain energy, okay, that is, since we provided heat, so we are supplying certain energy at point A. So what is going to happen? So this electron which was present over here, it will come out. It will become a free electron now, right? Sorry, it will become a free electron now. Let me just take these electrons out. That means what? Now these electrons won't rotate around the nucleus, right? Now it has become free electrons, right? So what does that mean? That means, can I say that this particular conductor is negatively charged? Since it has negative electrons, okay, so this particular conductor is negatively charged. I hope you are able to understand this. This particular conductor is negatively charged, and let's suppose if I am touching my finger, okay, over here, so my body is positively charged, okay, or what I can say, my body is neutral or positively charged, whatever you want to say. What is going to happen? The flow of electrons will be in this way. That means my electrons will flow in this way, and eventually all of these electrons will move inside my finger. Okay, this movement is being sensed by my finger, and thus we can say that the transfer of heat, because since electrons is transferring in my finger, that means what? I'm able to sense the heat or the energy which is being supplied at point A. Okay, I hope you are able to understand this particular point. It is very, very simple. This is how things work in case of electrical and electronics. This is very, very simple to understand. Again, I'll repeat. See, if I supply certain heat, so these electrons come out. So what I can say, come out of the outermost shell. So therefore, what I can say, this conductor is negatively charged when I touch my finger, right? Because my body is neutral, or I can say that my body is positively charged as compared to the conductor. Okay, so the electrons which are present over here, they will migrate inside my finger, and this migration is being sensed by me or my finger, and thus I can say that the transfer of heat is being successful from point A to point B. Okay, same thing will happen when I actually provide certain voltage. So let's say if I provide certain voltage, let's assume if I apply certain positive voltage over here, and negative voltage over here. So obviously now if you see the electrons which were present over here, what is going to happen? This negative charge will repel the electrons, right? First of all, we created a potential difference, right? I'll come to this particular point, don't worry about that. We'll come to this particular point. As of now, you just understand that we provided certain energy to this particular electron by supplying certain voltage. Again, I know that you all guys might not be familiar that what exactly is a voltage is, but just understand that we have applied or supplied certain voltage across this particular conductor. Okay, it's fine even if you don't know what exactly is a voltage. So what we did, we are applying certain positive voltage at point B. Let's say this is my point A and this is my point B. Okay, since we applied certain energy, okay, so what is going to happen? The electrons came out, and you can clearly see this negative voltage, or basically negative charge. Treat this negative voltage as a huge negative charge if you are unable to understand that what exactly a voltage is. Okay, so this negative and negative, they will repel each other, right? This negative and negative, they will repel each other, whereas you see this positive voltage, they will attract this electron. So these electrons will migrate in this particular direction. Okay, and eventually this is how the energy is being transferred from point A to point B. I hope you are able to understand this. Okay, I hope you are really able to understand this particular entire scenario. Okay, so with this, what we did, we actually concluded that what is present inside the conductor, which is responsible to conduct the heat and electricity, and what is not present in case of insulator. Okay, so I'll just quickly revise what we did. At first, I just give you one example stating that this is me staying at point A. At point B, there is my hypothetical girlfriend, okay, which stays at point B, and you are her neighbor. So I wrote some letter to her that is kind of confidential letter, and I expect that you won't open the letter. So I just gave that letter to you. What you did, you just pick that particular letter from point A, you just gave it to my girlfriend, hypothetical girlfriend, which is staying at point B. Okay, so basically you are like a medium in between both of us. Similarly, in case of conductor, the medium was nothing but electrons. Okay, by supplying certain energy, this electron was set free, and this electron was responsible to move from point A to point B, and this is how the energy is being transferred. Whereas in case of in case of insulator, the attraction between the nucleus and the outermost electron was quite high. So even by supplying a high amount of energy, we were unable to move these electrons out of the outermost shell. So therefore, there isn't any such free electrons that is being generated in case of there wasn't any such free electron that was generated in case of insulators. Okay, so let me just write over here, this is my insulator. Okay, and therefore no transfer of energy takes place from point A to point B. Even I supplied certain energy, I just failed to show that particular point. Even by supplying certain energy, I was unable to sense the energy at point B. Okay, and this is how things work. If I provide certain heat and apply my finger to point B, so the electrons will move from A to B as my finger is positively charged as compared to the conductor, which was negatively charged. Similarly, in case of voltage, when we apply certain voltage across a conductor, this is how things work. Okay, and with this I end this particular session. I really hope that you understood each and everything that we discussed till now, but still if you have any doubts, if you're facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts in the communication section. I'll be happy to help you out there. So thank you for listening me patiently. I'm ending this video over here. Thank you.